What makes volcano erupt? It's not just lava and heat. Sometimes it is a chemical reaction. In this video, we're going to dive into how reaction rates work using a fun and exclusive volcano experiment. Let's see how different factors can make a reaction faster or slower, and maybe even cause an eruption. Let's find out.
A reaction rate is simply how fast a chemical reaction occurs. In the case of our volcanic experiment, the reaction happens when baking soda, a base, reacts with vinegar and acid to create carbon dioxide gas, leading to the dramatic eruption. But did you know that the speed of eruption can change? Let's find out why.
Here is how we create our volcano. We place baking soda into the bottle and put vinegar on top. The result? Fizzing and bubbling. As carbon dioxide gas is released, this reaction occurs quickly. But let's see how we can make it faster or slower by changing a few factors.
First, let's try temperature. When you heat up a reaction, the molecules move faster, which increases the number of collisions in our volcano experiment. If you use warm vinegar, the eruption will faster and more intense because the molecules colliding more quickly. Let's see what happens when you change temperature on the vinegar.
up is concentration. This refers to how much of the reactants are present in a given amount of space. More vinegar or more baking soda means more particles to collide with each other, and that leads to a faster reaction. Let's see what happened when we increase the concentration of our reactants.
In some reactions, we can add a catalyst, a substance that speeds up the reaction without being consumed. While this experiment doesn't always need a catalyst, let's see what happens if we add a small amount of a salt of the vinegar. Catalysts help the lower activation energy, making the reaction happen more easily and quickly.
Finally, pressure can affect the rate of reactions, but only for gases. If we trap the carbon dioxide gas inside a sealed container, we increase the pressure and force the molecules to collide more. Speeding up the reaction, this would make the eruption even more intense if done in a larger scale.
So what did we learn? The reaction rate of our volcano experiment depends on several factors: temperature, concentration, surface area, and sometimes even catalyst and pressure. By adjusting these factors, you can control how fast or slow the eruption happens. Who knew chemistry could be this explosive?